Hi everyone. In today's challenge, we are going to solve this problem. The problem name is shortest path in a binary matrix, and the problem number is 1091. Alright, guys. So first of all, we are going to clearly understand this problem statement. After that, we are going to move to the logic part. We are going to see how we can solve this problem. And after that, we are going to move to the implementation part. We are going to implement our logic in C++, Java, and Python programming language. Fine, guys. Now let's see what this problem say. Right. So let's understand this problem statement. So problem says given an n cross n binary matrix grid, return the length of shortest clear path in the matrix. If there is no clear path, return -1. So guys, simple line it says that we are given first of all grid, a matrix, binary matrix. That means we will have only 0, 1 value in matrix, and the size is nothing but n cross n. That means it is a square matrix, right? All right. And now what we have to do, we have to find a clear path in this matrix, right? So we have to find clear path, and if there are exist more than one clear path, so we have to find the shortest path. So one thing is clear that if there are more than one path exists, so we have to find shortest one. And second thing, if there is no path exists, so we have to return -1. I hope this makes sense, right? So this is basically the meaning of this line. After that, let's understand this. What is clear path, right? So a clear path in a binary matrix is a path from the top left cell to the bottom right cell, such that there are two conditions, right? So basically, a clear path is nothing but, in simple word, we can say if we are able to move from 0, 0 cell to the last bottom right cell, that means n minus 1 to n minus 1. If we are able to reach from this cell to this cell, if we are able to reach from this cell to this cell, that means that path is nothing but a clear path, right? And there are some condition between this particular thing. If you are starting from this cell and you want to reach this cell, so there are some condition. The first condition is nothing but all the basic cell of the path are 0. So let's understand this with example. So guys, here if you are here, right, 0 comma 0, right, this is the initial starting we can cell, and you want to reach this 1 comma 1, right? So you can't take all that path which have value 1. You can take only those path, or we can say those cell which have a value 0, right? They have clearly mentioned all the visited cell of the path are 0. Means the visited cell should we have a value 0, right? So here from 0 comma 0, you can't take this path, right? You can't move to this cell. Why? Because this have value 1. You can't move to this one because this also have value 1. So you can take only this one, which is nothing but have a value 0, right? So the second condition is nothing but all the adjacent cell of path are a-diagonally connected. Now let's understand this one. So guys, let's assume you are standing here, right? So this is nothing but 1 comma 1, we can say index, right? So you can go to a direction from there. How? You can move to this one top, you can move to the left, you can move to the right, you can move to bottom, right? Now you can move to this diagonal as well, you can move to this one diagonal, you can move to this diagonal, you can move to this diagonal as well. So you have 8 possibilities from this particular cell where you want to move. I hope this making a sense, right? So you can move to 8 directionally at a particular cell. So these were the two conditions from moving 0 comma 0 to n minus 1 comma n minus 1, that you can take only those cell which have value 0, and you can move to 8 directionally at a time. I hope guys now you understood the problem. If I want to summarize it, so let's summarize this particular one, right? So basically, you are given one matrix, grid matrix will have a square matrix, and a binary matrix means having a value 0, 1. The second thing, we have to find a clear path in this matrix, which means we have to start from 0, 0 to reach n minus 1, n minus 1, such that the cell we are taking in between that particular path should not have a value 1, and we can move to a direction, right? And if there is exist a one clear path, that more than one clear path, so we have to return the shortest path, means the less number of cell we have visited. And if there not exit any single path, clear path, so we have to return -1. So this was the basically summarize of this particular problem statement. Now let's see the example, these two example, how the answer 2 came for this example, and how answer 4 came this next example, right? So here guys, I hope you understood this. From this cell we want to reach this, so we are taking only this path. So this is giving answer 2. How? Because they have no tell that we are starting from here, we have to reach this cell as well, right? So we have visited this one first cell. Now we can't take this one, we can't take this one, but we can take this one. So we jump to this particular cell from this cell, and we have visited this one also. So total cell we have visited nothing but 2. So we are going to return 2. But in the next this particular example, you will understand better how this particular answer, this particular grid have a 4 answer. So if you are here, right, let's say I jump to this particular cell initially 0, 0. So I have visited this one, right? So I have visited total one cell. Now I move to this one because I can't move bottom, it has value 1. I can't move to this one because it also have value 1. So I move to this one, and I have visited now those two cell, right? But I am here, right? Now I can move to this one. I have visited 3 cell. I have visited this 3 cell. Now I can move to this one. Total cell visited 4. Now I move to this one. Total cell visited 5. Right. So I reached to the last one, but I have visited 5 cell. This is a clear path, right? But this is not a shortest one. So we have to find shortest one. So the shortest one will be nothing but if we don't take this path, right? If we don't move to this one cell, if we directly move to here, then we are gonna we can say we can minimize our cost. We can minimize our length, right? So we can say now we just need to visit only four cell, 1, 2, 3, and 4. So total we can say optimal way or total the shortest clear path is nothing but four, because we have visited only four cell to reach this particular target cell. I hope this makes sense, right? So we don't only need to check the path, we check the value of the cell. We also need to check which one is the optimal one, right? So we could take this particular cell as well, but this is not going to give a optimal, right? We have taken this particular cell which is giving optimal. So the main logic in this problem is nothing but this only. We have to find the optimal one, so that where we can move, which can give us the optimal, or we can say shortest path, right? So how we can do this? Let's see the logic part, right? So this is come under logic, how we can solve this problem. So let me write a logic only, and here let's understand this how we can solve this problem. So guys, just want to ask one thing. Just tell me, whenever we need to find the shortest path in a graph, which algorithm you get in your mind? First algorithm, right? I hope guys you are getting a BFS, right? BFS is the only best algorithm we can say which help us to find the shortest path, right? So here also we are going to use a BFS only, and we are going to see how we can use a BFS to get the shortest path in this particular grid. So guys, BFS is nothing but work with a queue, right? So what we are going to do was, first of all, we are going to make one condition, right? That condition is nothing but if 0, 0 cell is having a value 1, so that means we could not even start to find a path, right? They have not given a guarantee that you are always be heading to this particular cell. They have told that we have to start from here and reach to there, right? So that means this particular cell can also have a value 1. So we can make one condition that if the initial cell is having a value 1, that means you have to return -1 directly. So it means there is no path exist, right? We could not even start to find a clear path. We need to start only when there is a value 0, right? If this is a value 0, then you have to use a BFS. So here we are going to say we are going to use a BFS, and how BFS is going to work, let's see that as well, right? So I'm going to make a first of all queue, and here guys I have initially I have only 0, 0 cell, right? I'm at this particular position and I have 0, 0 cell, and I have taken a one step. I hope this makes sense, right? Now we are going to move to the next. We are going to take pop out this particular cell, and we are going to see where else we can move from this particular cell. So once I pop this particular 0, 0, I can see I can move only to the right side, right? I can't move bottom. I can't move this particular diagonal. I can't move anywhere except this right cell. So I can say from 0, 0 I can move to 0, 1 only. Fine. So now what moving to this one, I took a second step, right? So total step is nothing but 2. Now I can say from 0, 1, let's pop this one as well. So I pop this particular cell, and before popping, I'm making it 1, right? So this is also 1, this is also 1, right? So whenever we are inserting this particular cell, we are making it 1. Fine. So now once we can say pop this particular 0, 1. So once I pop this, I want to check it where I can move. I can move to this direction. I can move to this direction, but I can't move there. I can't move back as well because this is already 1. So if I move to this direction, right direction, so I have to insert 0, 2 in my queue. If I move to this diagonal, so I have to insert 1, 2 in my queue, right? So I have by this I have taken third step, which is nothing but I can move to this one or this one cell. I hope this makes sense, right? Now once I inserted this 2 cell, I am going to make this 1 as well, right? So these are 1 now because we have visited this particular thing. Now let's pop out this 0, 2. So once I pop this 0, 2 cell, so this cell, so I'm going to say just see where we can move from 0, 2. So from 0, 2 we can't move this one, right? This is 1. We can't move bottom, this is also 1. We can't move diagonal, this is also 1. And we can't move the right side, which is out of bound. So we can say we can't move anywhere from 0, 2, right? So this is gonna give nothing to us, right? Now let's pop this 1, 2. From 1, 2 you can move bottom only, so which is nothing but 2, 2, right? And if you move into this particular cell, you are taking a fourth step. So guys, you can see we reach to the last cell, right? Whenever we are popping out this particular cell, we are going to check it if it is the bottom right cell or no. If it is yes, so return this particular step, number of step, right? So here you can see once we are going to pop this particular cell, so we are going to check it. Is this the last cell? Yes, this is the last cell of a grid, means bottom right cell. So you can see directly return step. So here we are going to return 4. So this is how our algorithm work, right? So you can see the BFS, how this BFS is going to help in this particular problem. Now let's move to the implementation part. Let's implement this logic in Python, C++, and Java, right? So here let me move to this one. So here guys, in Python, first of all, let me tell you, first of all, we have already solved this one. This is my second retake of this video. So first of all, what we are going to do, we are going to first of all check one condition, grid of 0, 0. We could say if this is a 1, so this is base condition, return -1 directly. If it is not so we are going to calculate the length first. So length of grid Now we are going to insert in our queue. So we are going to say queue is nothing but going to be collections, and here we can say dq, and here we can pass our 0, 0 cell, right? Initially we are here 0, 0. Fine. Once this is done, we are going to say while queue, we are going to find the size, which is going to be nothing but length of queue, and here we can say for I in range of let me write for I in range of size. Here we can say take out the pop out the first element first of all. So that is nothing but we can say going to give us row and column. So we can say q dot pop left, right? And here once this pop out the top element of q, we're gonna move to a direction. But before that we have to check if this row is equal to n minus 1. Let me write n minus 1, and this column also equal to n minus 1. That means this is the bottom right cell, so we can say return our step, right? And we haven't declared a step, so let's declare a step, right? Step is going to be nothing but 1 initially, right? Because we have taken a 0, 0 cell as well. Once this is done, if this condition true, then we are going to return answer. But if it is not true, so what we are going to do, we are going to say move 8 directions. For 8 directions, we can say direction is nothing but equal to 0, 1. This is 1, we can say 0, minus 1. So this is nothing but we can say right and left, and 1, 0 bottom, 0, minus 1, 0 down, and we are going to move all the directions as well, right? So diagonally 1, 1, 1, minus 1, and we can say minus 1, 1, and the last one is nothing but minus 1, 1, right? So this is nothing but 8 direction we have, right? Once we have got this direction, we are going to traverse over all these directions one by one for a, b in directions. And here we can say row is nothing but going to be not row already defined. So we can say current row is nothing but row plus a, and current column is nothing but column plus b. Once this is done, we are going to check first of all if this current row and current column means this particular cell is out of bound or no, right? So if current row is less than 0, or current column is less than 0, or current row is greater than or equal to n, or current column is greater than or equal to n, or we can say last thing is nothing but if grid of current row and current column is equal to 1, that means we can't take that particular cell, right? If any of this condition true, we are going to simply say continue. We can't take this particular direction, right? If it is not the case, that means we can take it, right? So we can say first of all make this grid current row and current column is equal to 1, means we are marking them visited, as well as we don't want to move this particular cell again, right? And we are inserting that particular cell in our queue. So we can say q dot append this particular cell. So you can say current row, current column. Once this is done, so once this loop is over, we are going to increment our step as well, right? So we are going to take new step again. So we can directly return minus 1 here. And why it is so? Why we are not returning here step? See guys, if there will be a path exists, so it will come in this particular condition, right? But if it not path exists, so it's going to come out this particular while loop, and we are going to return minus 1. Now let's see whether it's working fine or not. Let's try to run this code, and I hope it should work, right? No, it's not working. Why? Syntax error, invalid syntax. Well, let's, so we haven't passed here minus 1, right? Now let's run this code. I hope now it should work, right? And we're taking a time again. It's still saying invalid syntax. Do we have done something wrong? Let's see that. So if you will focus here, we have done any mistake or not? Let's check it. So direction, it is a to-do list. So we are doing everything is fine. It's fine, right? Okay, so we have used colon here. Now let's run this code. It is some syntax mistake. I don't want that one as well. Now you can see all the test case passed. So let's try to submit this code. And I hope it will also get submitted, right? And you can see guys, it's successfully submitted. Now let's move to the next programming language, that is nothing but C++. And here first of all we are going to check first condition, that is nothing but if grade of 0, 0 is nothing but we can say 1, so we can directly return minus 1. But if it is not the case, so find length, which is nothing but grid dot size, right? And after that you can say make a queue, which is going to be nothing but pair of integer, and this queue name is let's say queue, and we can say q dot push this particular, we can say we can say 0, 0, right? Initial step. And once you have pushed it, you can say int step is going to be nothing but 1. Now you can start our while loop, which is nothing but while q is empty, right? Q is empty, you can move it. So here you can say find out the size, you can say s, which is nothing but q dot size, and traverse over this size for int I 0, I less than s, I plus plus. Here what you can do, you can say pop out the first element, right? So we can say which is going to be nothing but auto data is going to be nothing but q dot pop, right? And you can say front also, right? And once you have done this front, you can say q dot pop, right? And here data we are going to check if data dot first is equal to n minus 1 and data dot second is equal to n minus 1, so you can simply return this particular step, right? But if it's not the case, so you are going to move to a direction. So you are going to again make an array, or you can say vector of int, right? So instead of this, if we could make an array, it will be easy, right? So we can say integer our directions array, and this direction I will have this direction. So let's make it. First we have 0 comma 0, 0 comma 1, then we have 0 comma minus 1, then we have 1 comma 0, then we have minus 1 comma 0, then we have 1 comma 1, then we have minus 1 comma 1. Let me write again the same mistake I was going to do, minus 1 comma minus 1, then we have minus 1 comma 1, then we have 1 comma minus 1, right? Once this is done, we are going to move to this particular directions array for int I is equal to 0, I less than 8, I plus plus, right? Fine, because there are 8 elements. After that, we are going to say take the current row. Int current row is nothing but going to be current row is going to be nothing but row plus not row here data dot first plus this directions, right? Direction of I comma 0, right? And after that, we are going to say int current column is nothing but data dot second plus directions of I, and here we can pass 1. Now we are going to check if it is auto bound or not. So if current row is less than 0 or current column is less than 0, or we can say let me write 0. So if it is, so let me just make it here, and here current row is greater than or equal to n, current column is greater than equal to n, or last thing which is nothing but grid of current row and current column is equal to 1. So we can't take this, right? So let's continue there. But if it is not the case, so we are going to mark it first of all visit current grid current row current column is equal to 1, and here we can say let insert in our queue. So queue dot push, you can push this particular thing current row and current column. In this while loop, you can say step plus equal to 1, right? After that, if this you are coming out of this while loop, that means you could not able to find a clear path, so you are going to return -1. So I hope this makes sense, right? So let's run this code and see whether it's working fine or no. It should work, right? But it's a semicolon error, right? Let's see, do we have any more error or not, right? I don't think we should get an error, right? So let's see. You can see all the test case passed. So let's try to submit this code as well. And by this, we have successfully submitted with C++. And here we go. We have successfully submitted. Now let's move to the next programming language, that is nothing but Java. And here in Java, what we are going to do, first of all, we are going to calculate the length. But before that, we are going to check if grade of 0 and 0 is nothing but equal to, we can say 1. So directly written -1. But if it's not the case, so find a length, which is nothing but grade dot length. Once you are done this, you are going to make a queue. So queue is nothing but going to be a pair, and pair size, and here you can say q is going to be let's write a q only. Q is equal to new linked list. So guys, let me define a pair class here, because we want to insert two things, row and column. So we can say class pair, and here we can say int first and int second. Let's make a new line, and here pair, and it's going to take a into b, and here we can say first is equal to a. Let me make it a better syntax, and first not first, now second is going to be equal to b, right? Fine. Once this is done, we are going to come here, we are going to say this here new queue we have created, and here initially you have to insert q dot, you can say what you can do, you can say add this new pair of 0 comma 0, right? And you can make a step is equal to 1. Here we can say while this q, we can say while this node equal to q dot is empty. So you can say what, nothing but you can find a first of all size, so which is nothing but s, let's say, and q dot size, right? After that, you can say for int I is equal to 0, I less than s I plus plus. So you can do nothing but you can say you're gonna take out the front element, right? What you can do, you can say q dot you can make it like pair only, right? Pair that is nothing but q dot remove. After that, you can say if data dot first is equal to n minus 1 and data dot second is equal to n minus 1, so you can directly return step. But if it is not the case, so you're going to move to 8 direction. So we can say let's 8 direction first. So we can say integer directions, and here let me write here here only directions, which is nothing but we can say 0 comma 1 first of all, then 1 comma 0 comma minus 1, then again minus 1 comma 0. Let me write here 1 comma 0. Let me write 1 only. Okay, and here we can now move to diagonal 1. So 1 comma 1 minus 1 comma 1 is 1, and 1 comma minus 1 1 comma minus 1, and the last is nothing but let me make it above minus 1 comma 1, right? So we have make a direction, 8 directions. We are going to move on these for int, and we can say arr of these directions. Here we can say current row is nothing but row plus this arr of 0. Current column is nothing but row plus arr of 1, right? Once we make this current row and current column, we are going to check it if this current row is less than 0 or current column, let me write, or note this one, current column is less than 0, and one more condition, that is nothing but current row is greater than n or equal to n, and current column is greater than or equal to n, or grade of current row current column is equal to 1, right? So if this is the case comes, so we have to directly return, we can say continue, move to the next tag. We can't take this tag particular step, right? Now if it is not the true, right, if all these conditions are false, so we are going to come to this particular thing, and we are going to add, first of all make this visited. So print current row current column, mark this one, so that means we don't want to move here, and next time, and after that we are going to move insert this particular thing in our queue. So we can say queue dot add new pair, and here we can pass current row current column, right? After that we are going to increase this step, and here we can return minus 1, because this will only come when we don't able to find a single clear path. Let's run this code and see whether it's working fine or no, or do we have any mistake here. Yeah, there's a lot of mistake, I guess. So this is row is not there, right? We have to use data dot first and data dot second. Now let's see anything else we have. It's taking a time, that means you can see all the case passed. So let's try to submit this code as well, and by this we have successfully submitted with C++, Java and Python, right? And this was an easy problem, isn't it? I hope guys you understood the logic part, problem understanding part, and implementation part in the three programming language. If you still have any kind of doubt, you can write in the comment section. I'm always there to help you. And if you learn something new in this video, don't forget to hit the like button and subscribe my channel. Meet you in the next video.